Hello.
Hello.
Hi. All right. Well, welcome. Did anyone have anything they wanted to share before we start?
Uh, Hello, sir. Hi. Good morning. So I was looking into some of the videos that the open house and the project views that's in the Oriel website in the YouTube. So I've been looking into some of the project overviews and like how do you expect to the DevOps group updates and all. So yeah, so last week I was like more of into understanding how is the space and all. So I was more looking into the videos and things that are and the repositories and how people have pushed the code and how they have committed and how the changes happen. So I was more into that. I was looking more into that.
It's good. Yeah. Glad you were doing some legwork into that and getting familiar with what we do. Yeah.
Yes, sir. I'm getting familiar with what exactly how things goes on and all, so that when we start off, so that it could be more cohesive rather than some new format or something sort of. But yeah, sir. I kind of
Yeah. It's good. So I don't know if Jesse had anything to say. I just wanted to introduce something here.
um, introduce something. I don't know.
Yeah, so I was going to talk about the blog, our medium. So this is our ORL group medium. And we have Jesse actually has been posting a couple things on Google Summer of Code and project management. The first thing, of course, was the April 5th post on applying to Google Summer of Code. Top tips for from a multi-year GSoC mentor. This is Jesse's experiences with applying to GSoC and talking about these do's and don'ts from the program. And I like this approach because this is reflecting on the many years that we've done this in the group and talking about not only crafting proposals, but how to interact at the org and some of the things that we do during the course of the summer or during the course of the season. So, you might want to read this if this is something that you want to kind of figure out. If you're interested in a successful GSoC application, or thinking about the program as sort of a mentorship opportunity, and that sort of thing. So, yeah, it's always tough. It's always a tough thing to get the proposal right. I used to spend a lot more time with students writing them, but I find that really the key to a successful proposal is sort of the way we do it in this organization is you have to take the problems that are proposed and come up with your own solution, but also do that in a way that's interesting to the org, and most importantly have a project management framework around it. That is, every week needs to be spelled out to some extent. You have to kind of know what you want to do and hit the ground running, and then have the ability to execute, and also to get around problems that you might have. So if you run into a problem implementing something, what will you do instead of that so that you don't fall behind in the project? The one thing about Google Summer of Code, and we'll find this out, but this is sort of talking about this in the longer term, is that over the course of a summer, you're going to learn how it is to manage a project and manage a project in a relatively constrained timeline. So if you can't do everything over the course of a summer, you can't do even maybe the things you proposed over the course of a summer. So you need to not only have proposed how to solve something with some actionable items attached to that, but then how am I going to sort of get the things done that are the most essential, that lead to some sort of finished product that I can, submit to Google, because they do want you to submit something that's more or less working, a proof of concept perhaps. How do I get to that? And, maybe how do I do things that are of high value to the organization? So in years past, we've done a lot of, packages where we've produced good software, good open source software that has continued on for multiple years. So this is Jesse's first post here on this, and then this is the post he just created. Like we talked about it in last Saturday's meeting in the Orwell Saturday Morning Neurosym. This is iteration beats stagnation. Momentum is a better beacon than progress. This is kind of following up on a lot of the stuff we have talked about in these meetings and over the summer period, in terms of how do you assess yourself and how do you assess whether or not you're doing good and you're doing well. And that doing well is really not about progress so much as it is momentum, that you have to keep working at it and building momentum. And that's what success is, rather than, say, looking at it as progress versus stagnation. So I'm glad he did this post. It has a lot of good stuff in it, a lot of nice conceptual drafts and things like that. So definitely that's our lab medium, the Orwell medium. And if you're interested in posting to the Orwell medium, please let us know. I can make you an editor and you can submit blog posts to this medium. Last summer, Sarrah Bastawala posted to the medium a lot. Paki Banchalia posted to the medium. So I mean, this has been a part of our GSoC experience, is posting blog posts, creating blog posts, maybe about your proposal, maybe about, maybe producing a blog post in the middle of the summer on your progress, or producing a blog post at the end to talk about the final project and how your experience. GSoC used to require people to do weekly blog posts, and they weren't really that involved. They were just kind of like updates. But we don't do that in this org. But we do encourage people to develop their writing skills, to be able to post things that maybe are useful to people in years to come. So Sarah's posts, I think, this is the work on open source sustainability. I think her posts are good. I think if Vidhi wants to go back to those posts and read them, I think they'd be very useful to her project. So that's good. So again, this is just one resource that we have. I encourage people to contribute to it if you can. And and so Jesse, I don't know now, if you want to take it away. And
there you go. Sure. There's a lot to come up. I actually wanted to write a few other things that reminds me of. I want to write a few other posts, maybe about I'd have make the most of your community period. At the very least, I don't know if I'll do that one, but at the very least, I wanted to. I'm in the process of reaching out to some of the current mentors or past mentors and past contributors to kind of, get some general advice from them. So if any of the mentors are watching this, or folks from last time, Sarah's here too. I'm going to try to put together a piece specifically about that soon. And there's many things in the series as a whole, like for Google Summer of Code, and then also definite. I cite Bradley at the start of the momentum versus progress one, but that was something that is directly. Bradley would kind of keep saying this thing. I'm for a while I'm well, that's nice, but then over time you kind of get it, and the more you actually are doing these things, okay, how do you, from the standpoint of someone working on a team or on a project, how do you do that? And then from the standpoint of someone leading the project or a more senior position in the project, how do you facilitate that? And those are really interesting dynamics. Those are the things that I find myself really enjoying that, which is why I'm like those discussions, which is why I'm doing some of this. So the next part of the series will be I worked with someone to help design one of the matrix images in the bottom of one of the posts, and it will basically be given this sort of decision space on this XY axis of time and where things are in the project. What should you do? Because what you should do to maintain momentum, or to maybe you park the project, maybe you go into sunset mode, maybe you reevaluate your priorities. All these different things in that space are realities that everybody faces all the time, and they happen in industry, they happen in academia, they happen in government, they happen in all areas. But like, what's affecting those decision spaces, will be different. Right now, in this course in summer, one of the implicit, well, it's explicit, but maybe not the highlight front page news of Google Summer of Code is like, yes, you are learning how to deal with project management and expectations. And one of the kind of key takeaways from the whole process is, how do you accurately communicate or prospect kind of a space that you want to have like your primary goal, and then reasonably pick something from the outset when you don't know anything, and then update it over time to your leadership, to your supervisor, saying, okay, well, I'm trying to go in this direction. Now it looks like this is going to be a tertiary goal, or here's what the more tenable destination is for the time period that we're talking about. But maybe in like a dependency or in a future goal and a follow-up, we can do this other stuff. So how do you do that? And that's not necessarily what the course is about, but that's sort of this looming lesson in the background for everybody is, oh, how do I hit the target that I really need to hit, and then communicate and get feedback about what sort of at the margin or beyond that. So this is maybe more, deep in the weed stuff. It will come up. It will come up in down the road. So yeah, a lot of things. Thank you for showing those things. A lot of those insights we've been brewing for a long time, and I want to keep the conversations going with them. And Bradley's been really good at helping to facilitate those discussions. And there's a lot of wisdom here, and I think it's fun to kind of try to encapsulate it into things that are a little more shareable than a lot of our great ideas are discussed here, but we want to kind of share them with the rest of the world. So we're trying to do that, which is important. Not just telling everybody else to make blog posts about what they're doing, but us to do it too in some ways. So it's good practice for me to do that together. There's I don't know. I was curious what else you wanted to talk about today, Bradley, because I don't have like any major big updates, but I have a few things I might say later. But I imagine you have stuff you want to get to before we do anything else today, or updates from other folks here.
Yeah, I have some lecture slides to share with the group. More on the lab, why it's named the Orthogonal Lab, and then some things on project management. I don't know if Morgan had anything to say. He has his camera on, so.
So it's my fault. Been certainly talking to lots of people interested in the new coding Boyden Institute that seems to be coming up around the work that they're hoping to do on capturing all C. elegans behavior. So hoping to find out more. I don't know if Jess has got any better leads on this work.
No,
and then
but I'll look
Okay.
into it.
Okay, please. So hoping to learn more, but and then in our new space, Joshua Bach was here and did his California Institute of Machine Consciousness. Not sure if that's exactly open source material, but yeah.
Great.
That was great through this week.
Yeah, I'm familiar with the. Well, I didn't know they were starting an institute on the C. elegans. Okay. Yeah, I'll have to look into that more.
Yeah, I think they definitely got initial foresight funding for that because I was at that AI and bio foresight meeting.
Yeah.
Yeah, I mean it was kind of long. A lot of foresight work seems to be kind of longevity funded, and so ostensibly we were talking about longevity, but there was a lot of great people there. Got to meet the head of generative AI for the Allen Institute, which was awesome. And I'm going to be up there for incorporating open data into undergraduate education in the middle of June. So really hoping to make lots of see lots of people while I'm up there too. So that should be cool. Yeah. Let's see if I can find out anything else.
Well, that's good. We'll have to look into that more. Yeah, that's great stuff. Like great stuff. Okay. Thank you, Morgan. Yeah, I don't, Jesse. I mean, I can do what I was going to do first.
Oh yeah, please. I'll like try to compliment whatever you're saying.
Yeah. So it looks like Rohit has joined. Welcome. And Sarrah and Mehul are here as well. Okay. So I'm going to talk a little bit more about. Of course, we're in the community period. This is the second week. So we're kind of easing into the summer and easing into projects, but we're also kind of doing these other activities. Sylvia's here. Hi. And so, I wanted to go over more about why we are who we are and what we do and why we do things. So, and then of course I also wanted to talk about this project management stuff because part of this is like, talking about contextualizing open source for people. But the other part is like linking that to managing projects, which you're going to be doing when you do open source. Part of that is, building code, doing things like that. But then there's also this project management component. And I think Jesse hinted at that there are all these moving parts that you need to kind of figure out what comes first, what comes second. You need to figure out like how you're going to build a system that will, if you're building a project, you're building a system and it goes beyond sort of this repository that you build, or if you contribute to a repository, because, there are all these moving parts that you have to know which ones are, should come first, which ones can come later, which things need to come next, and so forth. And then when people start using whatever it is you put out into the world, they have to be able to know how they can use it, what it's good for, etc. So we'll start with why we call it orthogonal research. So the title of our lab, and DivaWorm is of course part of this, it's also part of the OpenWorm Foundation, but the Orthogonal Research and Education Laboratory. So this is the official logo, and you can see that it's kind of like this, it has like three planes that intersect. And there's this tagline here, computation, empiricism, and theory. And we have these little weird symbols between them. And those symbols mean it basically means something that's independent of something else. Or in this case, it would be at right angles to something. So you can think of each of these planes as having a component of, inquiry. So This plane might be computation. This one might be empiricism. This one might be theory. And they're independent in the sense that you don't do them all at once. We have projects, for example, that are pretty computational, projects that are pretty theoretical, projects that are pretty empirical. And so you don't think about the theory or the computation up front. You don't, it's not part of your workflow. But what does happen is they tend to intersect. And the lab is at this intersection point between all three. So we have projects that are kind of going in different directions and they seem like they don't kind of articulate, but they actually do articulate in terms of how we approach all of these different modes of inquiry and ways of kind of thinking about a problem. Back in 2020, I published this paper, which was kind of like a paper that talked about a vision for the Orthogonal Lab. And this is on the meta archive. I need to update this paper because it's been, first of all, it's been like about 5 years now since it's been put out, but also there's a lot more I can say about what we're doing and why we're doing it. In any case, this is a nice overview of a distributed enabling computational laboratory, talking about this kind of vision that we have for this institute. And, kind of going through some of the things that we do here, some of our project management, what we call affordances, or ways that you can become involved, or ways that you can utilize technological tools to enable your work, things like that. So that's another paper you might want to check out. Again, it's, I've had a lot of good comments on this over the last 5 years, so I'm going to have to update this with some of the things that we've done since that paper was put out, and which has actually been a lot. I do have a video on, I think it's in the Open House playlist, that talks about kind of the history of the lab. And if you run across that video, and I was going through the slides, it kind of walks through how kind of it started, and then what we were doing, say, before the pandemic, and what we are doing after the pandemic. So it's like the pandemic, or the year 2020, was like a major shift in how the lab was run. And then we also had sort of things happening around 2017, 2018 that really made it, gave it a new dimension. So we, there are these milestones in the development of the lab. And so that video is, and I don't have it right now, but it's out there I think it's in the Open House channel. So check that out. It's a little dated, but it's a nice history of the lab and how it came to be. So orthogonal is an adjective. And of course, if you're doing machine learning, you know what this is. You know that they use that term a lot. The first definition is of or involving right angles or at right angles. And then number two is if you have a bunch of covariates or variates, it's the variates that are statistically independent. So you might have two variables that are independent of one another, meaning that there's no covariance. And so those are if you think about this in a space, those variables sort of exist at right angles to one another. And so this is what we're trying to aim for. We're trying to aim for sort of these intersections, not only between ways of doing research, like thinking about theory or computation or empiricism, but also different topical areas. So if you notice, we do things with computational agents, and we do things with philosophy, and we do things with neuroscience, and they all kind of come together as they can. You don't like infuse everything with all of the fields at once. You have to develop a strategy for this interdisciplinary approach. And so this is one of the ways that we kind of envision this. And of course, if you think about, interdisciplinary topics, people have tried for many years to characterize interdisciplinary space as like this network where you have different modules that represent different fields or different topics, and they're connected in different ways. So this network it's I think a citation network where you have different topical areas that are connected through like citations or through frequency of interactions. And so that's something else we can use to inform the space. How often are these areas generally in contact? What are their contact points? Can we add to this graph? Can we say there are new contact points to be discovered? Maybe they're fields that have not made contact with one another, and we can maybe, make those connections ourselves. So that's another kind of aspect of the orthogonal name, is that, we think about, and we often think about, say, like neuroscience and computation as these orthogonal things. We might use computational methods in neuroscience, or we might, build tools for neuroscience using computational methods. And of course, we have computational neuroscience. That's another sort of crossing point. But there, maybe so many more opportunities, and that's what we want to do. We want to know what those opportunities are. We want to make those connections. So that's a little bit about the name, just to make sure that we know why that is, and it informs our philosophy of what we do. Okay. And then there's the whole distributed aspect, which is where, we don't really have a physical location. We're doing all this online. We're all in different places probably. So that's the kind of our mode of interaction, is through teleconference, through Slack, through these other means. Okay, so I'm going to get into this set of slides, and I want to talk about something called working open, which is sort of a cognitive open source and open science. And then I'm going to go through maybe some things about open source, the history of open source, and how there's this sort of mode of production for open source, and a lot of good things to come. So let's start off. So when I teach about open source and working open is a variant of open source where people will take the skills of open source, being transparent, sharing code, having a mode of production that's allows you to, say, fork something and use variants of that thing, develop forks, which are modified copies of something, and then incorporate that into your workflow or into your working style. And, working open also involves doing teleconferencing and, online collaboration and all of this. So there's this whole set of skills that you learn, say in GSoC or in our open source, open science group. And you can apply it to a lot of different areas. This is an area that's kind of emerging as people are learning how to work with these technologies, as we're kind of engaging in new modes of production, as we're kind of engaging in, everyone in the world coming together to work on problems and things like that. So there's great interest in making this kind of working open or open source set of skills to become part of a greater skill set that you can go sell to people, to convince them that, you have something of value that allows you to lead projects or to build really good, interesting things. So, there are all sorts of open initiatives. There's not only open source, but there's like open government and open journalism. There's a lot of interest in making things open and transparent, and, collaborating together, sometimes virtually, sometimes using sharing a code base and not having to pay for things and have a large overhead. And so those are all things that are really interesting. But you have to sort of have the infrastructure. You have to have initiatives. You have to have formal skill sets, places to learn these skills. And so that's kind of what we're trying to accomplish here. I try to do in my class. And then, there are other places where you can see where this has manifested itself. So you have things like the Open Government Initiative, the NeuroMatch Academy, which we're kind of tangentially involved with. This is a virtual summer school that developed during the pandemic, and we were involved in it much more deeply at the beginning. But they offer this curriculum for people so that they can do a summer school. If you're anywhere in the world, you can participate as long as you have access to the internet. And, they go through like these 2 and 3 week intensive courses where you learn a bunch of things about topics like, computational neuroscience, deep learning, and I think they do climate change now. So it's a new way of offering education, a new way of engaging with colleagues from around the world, a new way of making connections. There's also working from home, which is, you think, well, working from home is real easy. I just sit down on my computer in my pajamas and I work, and that's it. But working from home as opposed to working in an office involves a huge shift in like how you manage your time, how you relate to your coworkers and things like that. It's very different. And, a lot of these, especially if you had like your own company or a company of 1 or 2 people, working in different places in the world, you need to have resources that are, open and accessible and transparent. So there's a whole shift there. And then we have to develop standards. So this is the FAIR standards for data sharing that INCF has developed. And so there are all sorts of standards we need to develop these kind of tools for working open. We don't want to have proprietary tools. I know we have Zoom for, for video calls. But one of the problems, of course, with Zoom is it's proprietary, and sometimes the overhead in terms of hardware is quite high. So we actually use Jitsi, which is actually an open source platform. So you can have all these standards that enable this kind of interaction, or sets of interactions. And so in the class that I teach, I go over the history of open source and working open. Open source software in particular started in the 1950s and 1960s in the domain of public software. So you had, various research groups who would publish software, and they would publish, things that they could share with maybe 5 or 6 colleagues around the world. And by necessity, they would have to share and maintain it sort of communally, and that was just the way it was done. Now, as computing developed, this worked against the traditional intellectual property rights of corporations. So companies like Microsoft were founded as sort of like these, proprietary software companies. You had these sort of collective open source pieces of software, but then you also had these proprietary pieces of software. And when Microsoft was starting out, they didn't quite know how to deal with the proprietary nature of their software. So they had these ridiculous demands of their users. Like you couldn't, you could buy a copy of the software on a disk, which was a thing then. And, you couldn't use it for certain purposes, and you had to, not share it at all. And there were a lot of demands on it that were maybe untenable for the growth of software, for the growth of teams and things like that. So this is always a tension between like this open source model and this proprietary model. But the open source model kind of came in more into the mainstream during the 80s, maybe from the 70s through the 90s. You had different pieces of infrastructure that were formed. You had hacking culture, which is where people would freely modify things. And that was a necessary component of open source, because before then you would manage things in these top-down teams where people told, managers told software engineers what to do, and they do it. And there was no room for innovation or experimentation, which was, of course, necessary for developing software. You had other public domain works. So you had models for public domain works, such as Linux, which was published by Bell Labs in 1970. Donald Knuth, who's a famous computer scientist, published TeX in 1978. And, having these models for thinking about, how do we produce software and put it into the public domain, that's important. That was an important breakthrough, to have those models where you can say, okay, here's how we do this. So if we want to produce some software and distribute it, this is how we do it. And then this, of course, evolved gradually into something called copyleft licensing. The first example of that being the GNU project, which was developed by Richard Stallman in the early 80s. So there was this kind of build up towards open source, with pieces kind of being put into place over several decades. Then, of course, we had Richard Stallman, who founded the Free Software Foundation in 1985, and his view of free wasn't like, they say it's like not like free beer, it's more like freedom or freedom of choice. And so the idea was that it didn't have to be financially free, but it did have to enable user freedom. In other words, you don't want to have these constraints on people using software. And a lot of proprietary software, like enterprise software, requires a lot of like constraints. You have to like put a dongle in your computer to run a piece of software or whatever. You can think of Adobe as a good example of this, where they kind of force you to do all sorts of, their license forces you into a lot of things. So the idea was to create software that had allowed people freedom to use it the way they wanted to. And then in 1998, the term open source actually came into common use. Christine Peterson from the Foresight Institute proposed the term open source because, they had all these ideas, but they didn't have a name for it. And open source is actually kind of a marketing term because it puts in people's heads this idea that, oh, okay, the source is open. This is, we can use the source. Because people, when they kind of, as computer science is growing, programming is growing, people didn't really know what to make of all the sort of the esoterica of user freedoms and, releasing things in the public domain. But people can kind of know what open source means. So once the term open source came into play, people kind of understood what that meant, what the sort of intellectual property model was, what the mode of production was. So when you define open source, you're denoting software for which the original source code is made freely available and may be redistributed and modified. So this is their definitions, like the free software definition and definition of free cultural works, which goes beyond software and into books and media and things like that. But the idea being that you make things freely available, you can charge for it. You can charge for, derivative works or something like that. But you don't want to limit how people can use something. You may want to open up the code so that other people can use if they buy some piece of software, they can modify the code if they want. And so the idea is maximum freedom of use. And, you also want to be able to modify and redistribute things as you see fit. And so that's kind of the idea. And it enables a whole bunch of things for organizations, for individuals. And so part of this, though, is about licensing. And so in my class, I kind of talk about the licensing and how that works. You have this copyleft mode of licensing, which is a set of principles governing open content that protects creators' rights. So copyright is where you say, I'm going to put a C on it, and you can't, look at this without paying for it. Copyleft is where, you can look at it, you can modify it, and there may be some, the creator gets to determine how and when things are used. And so that's a lot better for the creator, and that's a lot better for the end user. And it enables this whole infrastructure of working open source, etc. So a word about copyleft, there are different licenses we'll use for the software we produce this summer. There'll be the MIT license that we'll use. This is a software license that kind of defines the fair use of the software and then how people can use it if they, say, fork a repository or they make a copy of the repository and they modify it for their own needs. And all of those things are spelled out in the license. There are other software licenses, both for regular software repositories and for generative AI. Generative AI has its own set of licenses, and because it has its own set of needs. Then there are these Creative Commons licenses for content. You might have media, you might have other types of creative content that you want to put a license on, and those are also copyleft. So this enables open working, open source. So then I go through these 5 pillars of open source. You need to have publicly available source code, which you can host on GitHub. You need to have some licensing regime. You need to be able to allow for like free distribution and remixing. So no matter what license you use, that's a key part of it. It needs to be technology neutral. I don't want my software only to run, say, like on Mac Silicon. Ideally, I want it to run everywhere on every machine. I don't want to, run it on the latest hardware. I want to be able to let people, maybe who have, they can't afford the latest hardware. Maybe they want to run it on their phone. Ideally, we should be able to run things on all sorts of different technologies. And then versioning. So we want to be able to control versioning. And when we get into our repositories, you'll notice that, we'll have GitHub, and you've probably contributed to a repository. And the idea there is you make a push. So there's a pull request issued, and it gets accepted. But there's a lot going on under the hood when you do that. There's a current version of the repository. And then if you fork it, then you make a copy of that repository, and you have a copy. And then when you push something back to the main repository or the master repository, that then takes all that work that you've added on your fork and pushes it into that original repository. And those changes need to be merged with what's there. And things may have changed since you forked your repository. So all those changes need to be, they need to be sort of enumerated, and they need to be reconciled. And you don't want to have things overwritten, and you don't want to have work lost. And so version control is very important for that. Now, GitHub automates a lot of that, so we don't worry about that. It's all under the hood. But there are other cases where you use version control quite frequently. If you're doing things with, say, Word files, and you're passing a Word file between colleagues, and you're like, well, we want to make this Word file for like 5 people. And you don't have any rules as to how this works. You just say, okay, let's just add things to the Word file as we want. And so we keep adding things, but sometimes people will erase things, and you'll go back to the Word file and look for something and can't find it. So that's a problem for collaboration. So one of the things that you can actually do in Google Docs is there are versions of the Word file that you can go back to and restore old versions. So versioning is very important in managing working open, managing open source, and it's something to think about when we get into working with our repositories. Because even though GitHub does a lot of that in an automated fashion, you can run into problems with conflicts. And this is a problem that I've been having recently with some of my students. And sometimes they don't know the system as well as a lot. There's a certain level of getting familiar with GitHub. And if you're not familiar with GitHub, or you're not familiar with best practices, it can be a problem with these conflicts. So this is just to say that, I want to make you aware of a lot of these different things that you'll be kind of experiencing firsthand during the semester. So why should we work and manage projects in an open manner? And, you might ask, why do we work open? There are obviously benefits. Sometimes there are drawbacks. And we need to think about, when we work on a project, what those benefits and drawbacks are, so our project runs more smoothly. If we know that bandwidth is an issue for people, we want to be able to make, say, meetings accessible, or we want to make files accessible, or if they're working, if one part of our group is working on a Mac and the other part of our group is working on Windows, you want to make sure that they can access things equally. Or if we have some people working on mobile versus on a laptop, we want to make it accessible to everyone. So, a lot of this, if you think about a traditional project, especially like in a large corporation or, a company, the working open and open source requires a shift in perspective from that. It requires you to think about a lot of things differently, but also it gives you this toolkit for producing things in a way that's quite more accessible and quite more, there's a difference in what you're producing. So this is the open source productivity model. This is an example of the difference between closed source software and open source software. So when we think about like something like closed source software like Zoom or like Microsoft Word, I'm going to pick on Microsoft and Zoom a lot, but their model for distributing software is they have a piece of software that they develop in-house. They develop a program with source code. You get the executable, you download it, and it may be a free executable. It may be you have to pay for it. But the idea is you get the executable, you put it on your machine, and you can't modify the source code in any way. So it's closed in that sense. Everything under the hood is invisible. The program is maybe free, maybe you have to pay for it. And so everything is controlled by the organization making it. You just use it as a user. You interact with the graphical user interface, and that's it. So, maybe you want a new feature, and you can't add a new feature because, it's something that is not on their roadmap. So that's a problem sometimes. Maybe it's a big problem. Maybe you can't use that piece of software because of that lack of a feature. So one way to solve this, of course, is to adopt an open source software model. And so now we have this open source productivity model that, of course, involves source code, and it involves producing a program, and it involves distributing the program to users. But say I want this new feature and the software doesn't have the feature. What I can do in an open source model is I can go to the source code, maybe on GitHub, and I can fork that source code. I can make a copy of it and open it up in my GitHub, in my own GitHub account, in a repository that I forked. I can modify that code as I see fit. I can maybe build a new feature into that, and then I can release that executable eventually as a new modified program that involves that new feature. And so you can do this whenever you want to create a new feature. You can have multiple forks, and depending on the license, you can distribute those as you see fit. So this creates an opportunity for people who use the software to be producers, not just consumers. And you have a lot more variety in what gets produced because the product team, maybe at Microsoft, they can only put so many different features into a piece of software. And your feature might not be a priority on their roadmap, or they might just simply not care. And so you can create something that you with the features you care about. And so the idea is that there's a lot higher productivity because you have all this variation in the product. And that can be both good and bad. That can be good because it gives people what they want, but it can also be bad because you don't know necessarily which version is best for you. There's so many versions that it's like, as a more sort of passive consumer, you're like, I have no idea what version to pick. And you see this with Linux all the time, so that's why I bring it up. But there's a difference then between that productivity between the closed source model and the open source model. And so this gives us these open source genealogies where we have like an original source project, and that original source project might get forked due to a lack of a feature or something else. Or sometimes you might have a fork that is created because there's a disagreement in the development team. One part of the development team might want to go in one direction, another part of the development team might want to go in another direction. And I won't say any more about like team management right now, but these kind of disagreements happen all the time. Apparently, that's what's happening with Apple's foray into AI, is that they're not on the same page in terms of how they want to implement it. And, so this is like, I'm not saying open source would solve that problem, but I'm saying that open source could give you, rival approaches, and you could just evaluate them and see how they work. So you end up with these genealogies where projects get serially forked, And you end up with this fork tree. This is the Red Hat family tree, which is all the forks that have arisen from Red Hat. So Red Hat was released in 1993 as a single program, single project that produced this version of Linux. And then since then, we've had all these forks. We've had forks of forks. We've had forks of forks of forks. And you can see in this case that there's quite a bit of diversity there. We've had forks because people wanted specific features. We've had forks because development teams wanted to go in a different direction. We've had forks that were maybe made for a specific purpose. And so you can see that in this tree, you have a lot of different versions. Sometimes these forks die off, which they just stop being maintained. They stop being developed. Sometimes they're only around for like a year or two because it was like a limited edition or something, But the idea is that there's a lot of variation in Red Hat development, and the idea is that this has persisted for 30 years. So open source allows us to allow a project to persist. It gives us the freedom to add features when maybe a core development team doesn't see the need. And it gives us a lot of variety in how Red Hat is implemented. And so, again, maybe there are some security drawbacks to this. Maybe there are project management drawbacks to this. But you can see that this is clearly kind of a different mode of production than, say, like a project that's managed in a larger organization, is managed in a top-down way, and that has has its evolution, but it's not anything like this. This is an example of sort of how open source software has evolved in different platforms. I'm trying to remember where I got this figure from, but this is like the Unix kernel and how it evolved from like 1969 onward. So you can see that there are differences in how they've approached open source. So some of the kernels have been open sourced, some of the kernels are closed sourced, and some of them are mixed. So you can see these genealogies that are kind of like, some projects are fully open source, some kind of change their policy over time, and some branch off because they want to pursue a different strategy. So it's all kind of thinking about long-term management of your projects, long-term management of software. And so then the final thing that I talk about in this lecture is that this whole idea of working open and open source, it really runs on what we call social capital. So social capital is where you're not worried about like financial transactions. You're worried about transactions of trust or transactions of reliability. And they're things that people evaluate you on in these social relationships. So, you have these different, let me see if I can get down. Oh, I can't get down to that. I usually break this out into the different forms of social capital. But, there's like trust, there's consistency. There are all these attributes that people, when you exhibit those, like if you want to run an open source team, how do you manage a large open source team? Well, you could pay people, okay, but that doesn't ensure that they'll do a very good job. That's what they do in corporations, and you have people who feel like they have a stake in the organization, but sometimes people don't. You also need to have trust, and trust comes not just in open source and working open, but also in these proprietary organizations. If you want to manage a project in a proprietary organization, you have to have the trust of your team. But it's important to realize that social capital is important. It's important. It's like a glue that keeps groups together. It keeps them sort of thinking about, common goals. It keeps them motivated. And it works a lot better than kind of like purely financial incentives or things like threats of being fired or things like that. So if we can kind of figure out how social capital is exchanged in these groups and how people respond to different incentives that are more social in nature than, say, like financial, we can really kind of make things happen and crack the code of how to manage teams that are pretty unruly otherwise. Now, of course, we have our project, Open Source Sustainability. We actually are thinking about this problem because we're thinking about how do open source teams maintain their stability, how do they maintain productivity, and we're thinking about all these social capital aspects, right? We're thinking about task size, skills, but then also trust, and is there a clear objective, which makes people think that okay, this is a worthy project. There are all sorts of subtleties here. Okay, so there's this article from Harvard Business Review, The Hidden Benefit of Giving Back to Open Source Software. And this kind of talks about how open source projects are oftentimes thought of as a public good. And again, it feeds into this idea of social capital, because a lot of times open source projects, like Linux or something, like Wikipedia even, is a public good. It's not something that it's not a for-profit enterprise like maybe like Zoom or like Microsoft Word. Zoom, of course, has enterprise versions that they charge quite a bit for, and so forth. So, we're not really in it for profit seeking. We're in it for building public infrastructure or having something that can be shared with a larger community of people. And so, that's great that we have this. There's, of course, a benefit in giving back to that kind of a project because it helps build this public infrastructure. But there is something that people who contribute to these organizations can gain, and that is that companies, proprietary software companies, and other kinds of companies are looking for the skill set that involves people who have experience with open source organizations. I've had a lot of former interns, people doing GSoC, people doing our open source internship more broadly, who have gone on to different jobs in different corporations. And I've enjoyed revisiting this over the years. You go to LinkedIn or, you get emails from people and they say, oh yeah, I joined this organization, this company, like a bank or like Netflix or some other company. And it's really fun to see where people can go. But moreover, a lot of large corporations want to have people who are conversant in open source, because they want to use open source tools and they want to have they want to reap the benefits of open source within their organization. Sometimes large companies will do proprietary software development, but then have an open source aspect, like Microsoft is open source. And, that's a different wing of the company, but it's something you need people who are conversant in open source to run well and get the value out of it. So the final slide is about something called the Debian social contract. This was something that goes way back to 1997. And the idea is that you want to start off early in your project thinking about the larger values that govern your project. So it's about governance. It's about how do we maintain our project as it scales up, as it grows. How do we make sure our project stays true to what we want to do? And there has to be this social contract. So they lay out some aspects of a social contract. And this formed the basis for the open source definition. So this has like some historical significance. So in the Debian social contract, they ensure that software remains open and free as it gets forked or scaled up. We want to make sure that we don't develop free and open source software, and then as our organization grows and as we want to sort of have the urge to make money and become a for-profit organization, we don't just say, well, we'll just become a for-profit organization. A lot of times you want to maintain free and open source software, and that's the goal of the organization. But to do that, you need to have some of the social capital, some of this glue in place. There are 4 points that they mention. The first is that, a lot of individual contributors have to be willing to gift improvements to the community. So the community exists as a group of contributors, a group of users. They have conversations. They may contribute to the software in different ways. And a lot of times people want to keep innovations themselves, but you have to be willing to gift improvements to that community. You have to exhibit transparency in methods, software, and organization, meaning you have to show your work. You also have to be upfront with your community about the decisions that are made in governance. So if we decide to go for this contract or we decide to add this feature, everyone has a say, more or less. You need to be able to stay focused on users and the software. A lot of open source organizations will drift off into other things. Their mission will change. And when you change the mission, you sort of violate the social contract, but you burn up your social capital. And so your glue of your community and your project dissipates. And then finally, we want to enable the use of free software with non-free software to make sure that the free software option has like some, weight to it. So it doesn't, there isn't this temptation to say it's not worth anything to anyone. So that was the slides that I had to share. I hope that was useful to people. Looks like, let's see, we have some things in the chat here. So, Layla said the Medium blog post is interesting. Vidhi says she'll definitely go through Sarrah's post. And then Jesse had a couple comments on the Orthogonal Lab and talking about how we're a distributed collaborative organization. He said it was a major shift, but we were always virtual remote focused, right? Yes, we've always been virtually remote focused. Yes, it is a major shift from like a group where you're in person, in an organization like a company where you're all working in an office. You might have collaborators in other places, but you're not you're in nowhere. We're kind of all in different places, different time zones, maybe different cultures, but we come together for this purpose. And so it's a lot harder to kind of maintain that glue. That's why we need to use our social capital to do that. Jesse also says Neuromatch is still looking for project mentors. I may join that front. Very good. Mehul said the peers at Neuromatch are amazing. People from different backgrounds, undergrads and grads, all very research focused. Yeah, if you're interested in neuroscience, you're interested in machine learning, deep learning, that is a good summer school. And it's totally run by volunteers. It's totally kind of like this, where it's sort of working open. You have open notes and you have this sort of distributed collaborative mode of interaction. Okay, it's Layla says, a great presentation. Could you please share the slides? I'll share the slides in the Slack so people can see them later. Okay, so do we have anything else we wanted to talk about before we go?
Up here. I've moved everything around, so now I'm looking up here. That's kind of weird. Nothing major. I will say, I get this over here. I will say, I appreciate the presentation. I will try to be reaching out to a lot of the Google Summer Code contributors and mentors of like former ones over this week to catch up with folks. A little plug for Data and Direction. I've been doing the interviews for that internship, and it's been really, really fun and heartening to see people care about data ethics in terms of wanting to do things about it and wanting to do rigorous stuff. So more about that tomorrow. And I think one of the things I'm also curious, because this is sort of the community period for Google Summer of Code and what we're doing here. And a lot of our job is to kind of give context for the open source community and the lab and all that stuff. But if there are questions about doing things in open source, it can be about the project in specific, but also like professional development related questions or topics you were interested in hearing about more. Some of which I'm sure Brad will say, we're going to talk about that next week or later on. But we encourage feedback, and also we have the opportunity to tailor some of our content to any pressing questions or issues you have. like I'm writing a whole bunch of stuff in this space and trying to sort of aggregate many discussions over the past several years here. So if anything you kind of would appreciate having us focus on for you to have more of a discussion about in this meeting or tomorrow and other meetings, let us know, because there's a lot to choose from, a lot of important stuff. But that's my outro pitch for all those things.
Okay. Yeah, I think that's great. Thank you, Jesse. So yeah, next week we're going to at the final week of our community period, and I want to start getting in the habit of people who are doing GSoC especially, but also everyone kind of giving an update on what they're doing. So we're going to use kind of a check-in model like they do in Agile, and I'll kind of go over maybe next week how to do that. And I want to see what works best. I think that'll be a good way. And then during that period, you basically give an update and then give maybe a demo of what you're doing or whatever. And we'll go through it, and that'll be kind of like if you do that every week, it like keeps you up to date not only with your sort of auditing yourself, but then seeing what other people are doing.
Yeah, I think that'll be really good, and just formalizing and normalizing it is every culture and community will do it differently, but I think it's really critical in how we do things here to do it that way. And, it just is I think we'll have a much more extended discussion on this ahead, but it can really just be something that you eventually, I think you kind of get to a place where you think about it during the week, like, oh geez, this is something I should bring up here, or it's sort of creating these like micro elevator pitches of what's going on, or even just an interesting thought that you have that you want to share with the group about the project or open source or whatever. So I look forward to that, and I'll try to have something prepared for that next week myself.
Anything else before we go? All right. Well, thanks again for attending. So we're going to do this weekly. So next week and the week after. So yeah. Thank you.
All right. Take care, everybody.
Take care.
Take care.
Take care.
Bye.